Okay, good morning, class. So last time we have started the chapter that is called as cholinergic agents. Okay, so we have seen the chapter that is the adrenergic agents, which consist of adrenaline, noradrenaline, that is epinephrine, norepinephrine, and third one isoproterenol as the agents which can bind to the receptor. So out of which adrenaline, noradrenaline were the synthetic one, adrenaline, noradrenaline, they were the natural, while isoproterenol was the synthetic. Here we have started it is the cholinergic agents in which the neurotransmitter is acetylcholine. Okay, so it binds to the cholinergic receptor and they will perform the functions which are associated with the cholinergic drug system, cholinergic system. Okay, so the acetylcholine, this is the structure of acetylcholine. As the name indicates, acetyl and choline. So this part is called as the choline, or it is the this is the ester. So ester is made up of alcohol plus acid. So here we can say the alcohol which is present is the choline and the acid which is present is the acetic acid. So together they form a neurotransmitter. That neurotransmitter is called as acetylcholine. This acetylcholine binds to the cholinergic receptor and they will perform their function. So this cholinergic nervous system is responsible for the impaired or excessive gastric acid secretion, then glaucoma to increase the pressure on the eye, bradycardia, slow heartbeat, Alzheimer's disease, myasthenia gravis. So such part is associated with the cholinergic agents or the cholinergic nervous system. In this we have already studied. So what is acetylcholine? So acetyl along with the alcohol when they get come together they form a acetylcholine. So acetylcholine is the neurotransmitter which can binds to the cholinergic receptor. So there are two types of cholinergic receptor to which the acetylcholine binds. One is the muscarinic receptor. So this muscarinic receptor generally is agonized by a chemical or the compound called as muscarine. And second one, nicotinic receptor is generally agonized by a chemical called as nicotine. So this muscarinic receptor, they are of five types: M1, M2, M3, M4, M5. Nicotinic receptor, they are of two types: NM receptor and NM receptor. Next part, that is the SAR of cholinergic agents. So as we have seen, if we have to prepare a agonist or antagonist, they should have the similar kind of structure which are related with the neurotransmitter. If such structure is present, they can work either as an agonist or they can work as the antagonist. So the slight modification of the drug, it can lead to the agonist or antagonist type of structure. So similar kind of structure we can develop by using the structure of neurotransmitter called as acetylcholine while developing a cholinergic drugs. Okay, so cholinergic drugs mimics the action of acetylcholine, which binds on muscarinic or nicotinic receptor and produces the same effect. But the magnitude of this effect is more as compared to the neurotransmitter. So the generally making the strategy as an agonist, we should know the structure of acetylcholine, which consists of acyloxy group, then CH2, CH2 that is the ethylene group, and finally there is the presence of quaternary ammonia. So while developing a cholinergic agents, we should have such kind of structure in the drugs or the chemicals so that they can bind to the receptor or they will bind to the activity. They will elevate the activity. So such kind of structure must be present in the given drug so that they can bind and they can produce the high activity. Okay, so the first part we will start with the quaternary ammonia. So already we have studied in the quaternary ammonia there must be the presence of quaternary ammonia. So this nitrogen must be bind with the four atoms or four different groups so that it becomes a quaternary ammonia be having the positive charge on the nitrogen. So this presence of nitrogen atom is important for the agonist activity. This nitrogen cannot be replaced by any other heteroatom like sulfur, arsenic or phosphorus. If we are replacing the nitrogen with such atoms, then it will reduces the activity. Then presence of three methyl groups, it is necessary for the activity. Okay, so here 1 2 1 2 and 3, so there are three methyl groups must be present. It should be attached with the quaternary nitrogen. Okay, so here you can see the replacement of nitrogen with the sulfur. It causes reduction in activity. Similarly, phosphorus, arsenic, if they are present, they will reduces the activity. So what is the conclusion? What is the SAR regarding the quaternary ammonia is that the positive charge is needed. This positive charge must be on the nitrogen atom, and this nitrogen atom must having the four bonds. So this is the first point of the SAR. The nitrogen atom or the quaternary ammonia must be in the quaternary form. You cannot replace the nitrogen with any other heteroatom like phosphorus or sulfur. Second one, it must be positively charged. And third one, four atoms must be attached to the nitrogen. Next, we have seen that the three methyl groups must be present on the N nitrogen 1, 2, and 3. So, if three methyl groups are present, all three are the methyl group, the drug becomes active. But instead of methyl group, if we increases the chain length, so methyl group replaced by the ethyl group. So all these 1, 2, and 3, if they all three groups they consist of the ethyl group, then what happens? The drug becomes antagonist. And if we increases the chain length further, propyl, butyl, then the drug becomes inactive. Okay, so the optimum or the better activity, there must be presence of three methyl group. Second part, if ethyl groups are present, drug becomes antagonist, and if higher alkyls are present like propyl, butyl, pentyl, then the drug becomes completely inactive. Now it is in the case of all three atoms if we are replacing. If one of the atom we are replacing with the ethyl or propyl, the drug remains the active but its potency decreases. And if all these are three R's are hydrogen, then the drug becomes NH3, okay, NH3 plus along with this part. In such type of drug, there is a activity goes on decreasing as we are replacing the R group or the CH3 group with the hydrogen. The next part, the center part, that is the ethylene group. So as per the rule, that is the rule of 5, rule of 5. So what the rule tells that the distance between this quaternary ammonium containing nitrogen and the hydrogen which are present on the terminal carbon, the distance between these two must be occupied with the 5 atoms. Okay, so here you can observe clearly 1, 2, 3, 4, and 5. So the distance between this hydrogen and this nitrogen is occupied with the 5 atoms, and it gives the optimum activity. That is the rule of 5. If we change the distance, if we increase or decreases the distance between these two, then the activity decreases. If we are adding ethylene group, if we are adding one more, that is the 3 carbons, if we are adding, that is the propylene group is present in between, then the distance between the nitrogen and hydrogen increases and the activity decreases. Or if we keep only one methylene group, then the distance decreases as well as the activity will be decreases and the activity is rapidly lost. So it is necessary to have ethylene group in between these two, that is the nitrogen and this oxygen. If it is absent or it is having the more than one, that is the one only methylene group or propylene group, so it will lost the activity tremendously. Okay. Now, two methyl groups are present. So this methylene is alpha. This is beta. If methyl group is added on this beta carbon atom, then it retains the potency and it becomes more selective towards the muscarinic receptor. And such compound, the name of such compound is called as methacholine. And if methyl inclusion on this alpha carbon atom relate to the N, then it reduces the potency, but the drug becomes more active towards the nicotinic receptor. So what happens? Two ethylene groups are present. So if we are adding the methyl group at alpha carbon on this carbon, then the potency decreases and selectivity towards nicotinic receptor increases. If we are added to the beta carbon, this CH3 group, then the potency also increases or it is activity is retained, as well as it is become more selective towards the muscarinic receptor. So we have to add a methyl group on the beta carbon, and if such methyl group is added, then the drug becomes drugs having the asymmetric center and it becomes or it produces the different isomers, and out of which one isomer becomes more active as compared to the other isomer. Okay, so this is beta carbon, the drug becomes methacholine. This is alpha carbon, so drug becomes more active towards the nicotinic receptor. Then the last point regarding the SAR of these acetylcholine agonists, that is this part. So it consists of acetoxy group. So this acetoxy group is not necessary for the activity, but it must consist of the oxygen. So if acetyl group with higher groups such as propenyl or butyryl, then the activity reduces. Suppose if R is C3H7 or C4H9, so higher than this, the activity reduce. The ester group, as I told, it is not mandatory for the activity, but at least of one carbon or one oxygen is required in this region, so that we can replace this acetyl group with the carbamate, ether group or ketone group with these acetyl group. After replacing this one, its duration of activity decreases, its metabolism rate also decreases, and duration of activity increases. As we have seen here, if ester group is present, then it can undergo hydrolysis easily, that is the ester hydrolysis, and its duration of activity decreases, as well as the metabolism takes place very fast. If this ester group is replaced with the carbamate, ether and ketone, as only the one oxygen is required or at least one oxygen is required, so we can replace this acetoxy group with the carbamate, with the ether or ketone. And if such replacement takes place, what happens? The duration of activity increases, as it does not have ester, so it is difficult to break down these bonds. Okay, so this is carbamate, NH2 group hai, this is ether and this is ketone. So such changes we can made so that it will produces the drug with the more duration of activity. Okay, so this is the SAR in very short. Okay, so quaternary nitrogen is required. It must consist of 3 methyl group. As the rule of 5, there must be presence of only 2 nitrocarbons between this nitrogen and oxygen. So methyl group at beta carbon increases muscarinic selectivity, retains the potency. Methyl group at the alpha carbon, it will reduces the activity and increases the selectivity towards the nicotinic receptor. Ester group is not mandatory, so we can replace this ester group with the carbamate, ether and ketone. So these are the points or the important points which comes under the SAR of cholinergic agent. So now we have studied the SAR for the cholinergic agents. Now next part, what are the pharmacological actions of these acetylcholine on the muscarinic receptor? So in case of heart or in case of cardiac functions. It causes the bradycardia, it decreases the AV conduction and also decreases the strength of contraction. In case of blood vessels, it dilates the blood vein and it causes the release of nitric oxide. Okay, so the dilation of blood vessels takes place. So when we are giving the acetylcholine as an injection, it will be responsible to release the nitric oxide NO. And we have studied in the last semester that is nitric oxide is responsible for the vasodilatation. Okay, so the blood vessels get dilated. Then in case of smooth muscles or intestine, it increases the tone. Uterus is also increases the tone. It causes bronchoconstriction. In case of secretion, it increases saliva, that is increases the digestive saliva, bronchial, sweat, tears, that is the lacrimose secretion. So such kind of secreted substance can be increase the secretions due to the acetylcholine, and it decreases the iris diameter. It causes the meiosis, which can lower the intraocular pressure. And when they are concerned with the nicotinic receptor, or when this acetylcholine binds to the nicotinic receptor, it is responsible generally in the case of nerves or in the case of neuromuscular junction. So it causes skeletal muscle movement, and at high dose it causes muscle paralysis. And in case of brain, the cholinergic deficiency, it will lead to the Alzheimer disease. Okay, so these are the points which are comes under the pharmacological activity of acetylcholine when it binds to the muscarinic receptor or it binds to the nicotinic receptor. So generally nicotinic receptor it responsible with the neuromuscular type of tissues or the cells, while muscarinic receptors they are present in the heart, different body system, in the digestive system, okay, in the iris also they are performing their functions. So they are performing their functions into these different ways. Now next part, what are the way for the synthesis of acetylcholine and how the acetylcholine is synthesized in our body. So it starts with the amino acid called as serine. So when serine is present in our body, this serine undergo decarboxylation reaction, and when it undergo decarboxylation reaction, the CO2 from this part, that is acidic part, it is removed, and when the CO2 from this part removed, it forms choline and the alcohol which is responsible for the formation of acetylcholine. Then this acetylcholine, with the help of choline and methyl transferase, the methylation of this amine group takes place in methyl transferase. So the name indicates the methyl group is transferred to the nitrogen, and until and unless this quaternary amine is formed, this reaction or this step proceed 1, 2 or 3 times until and unless we are not getting this part. So this quaternary ammonia which is present on the choline along with the acetyl CoA, with the help of enzyme choline acetyl transferase, it forms the acetylcholine. So acetyl group plus choline group is converted into the acetylcholine. So in this way the biosynthesis of acetylcholine takes place. So in our body, serine is present or serine is synthesized. This serine undergo decarboxylation reaction. It forms choline. On choline, the N-methyl transferase enzyme acts. So methyl group is attached to the nitrogen. The reaction stops until and unless the nitrogen is converted into quaternary ammonia. And after that, along with the acetyl S-CoA coenzyme A, it reacts and it forms the required neurotransmitter. The neurotransmitter is the acetylcholine. Next part, we are moving to the next part. What are the agonists which are present for the specific muscarinic agonist? So drug other than acetylcholine produces the same kind of effect that acetylcholine shows. For example of agonist, methacholine, carbachol, betanicol, pillocarbin. So these are the muscarinic agonists which can be given to produce the cholinergic effect. So instead of acetylcholine, where acetylcholine binds, that receptor these drugs bind and they will produce the activity with greater intensity and for the longer time. As we know that acetylcholine is the ester, so we cannot give acetylcholine as a drug. If we are giving acetylcholine as a drug, it will undergo hydrolysis reaction and their decomposition takes place, so it will not useful. Hence, instead of giving the acetylcholine, we are giving the different drugs which can bind to the receptor and which can produces the similar type of cholinergic reactions. Then mechanism of action of these agonists, they directly act by binding to the muscarinic receptor and produces same kind of effect what the acetylcholine shows. So the muscarinic receptor cell, nicotinic receptor cell, instead of acetylcholine, these drugs binds and they will produces the effect similar type of acetylcholine with the longer duration of activity and along with the greater intensity. So the first drug of this agonist is methacholine chloride. Okay, so this is the structure of drug methacholine chloride. So as we have observed, as we are told that some specific chemical structure is required to produce the agonist effect, and similar kind of specific structure is present in the given drug like methacholine, which is required to produce the agonist activity. So here quaternary ammonia is present. It is also present in acetylcholine. Ethylene group is also present, and here on beta carbon there is a CH3 group is substituted, and substitution of beta carbon it indicates muscarinic activity than the nicotinic activity. Then similar kind of acetoxy group is also present. So if you find the structure, you can find out that the beta methyl group is present, which produces the muscarinic type of activity rather than the nicotinic kind of activity, and it maintains the potency of acetylcholine. So methacholine is the muscarinic selective cholinergic agonist, and when CH3 group is present, the drug becomes asymmetric. That carbon becomes asymmetric. So here hydrogen is present. So this carbon having 4 different groups. So this carbon it becomes asymmetric. So it produces enantiomer, that is R and S enantiomer. So S enantiomer is 240 times more potent as compared to the R enantiomer. However, R isomer is weak inhibitor of degrading the enzyme called as acetylcholine esterase. So generally this drug is given as a racemic form or in the form of racemic mixture. So it is used to induce bronchospasm in asthma patients in the diagnosis of asthma. This is methacholine. Next one, carbachol chloride. So we have in SR we have seen that if we are replacing the ester group with another groups which consist of oxygen, then also they will perform similar type of activity. They will have the similar kind of potency. So similar here the carbamide group is there, which is the analog of acetylcholine. So here you observe instead of ester group, that is the carbamide group, so NH2 is present instead of CH3. All other are the same. And if such cases takes place, so it is difficult to hydrolyze these ester by the enzyme acetylcholine esterase. So this drug can be given orally. But as there is no alpha, no beta, here is also no methyl group, here is also no methyl. So this does not have any kind of selectivity to the muscarinic receptor or towards the nicotinic receptor. Okay, so if you observe the structure, if ester is there, it can undergo hydrolysis, its duration of activity decreases. But due to the presence of carbamide group, this is NH2 group, it becomes resistant to hydrolysis to the enzyme acetylcholine esterase. Hence, it can be given orally. But the main problem with this, it is not selective. So it is not selective towards muscarinic, or it is not selective towards nicotinic. In methacholine, as it consists of beta methyl group, it is selective towards the muscarinic receptor. But here there is no substitution, so it is not selective towards either muscarinic receptor or towards nicotinic receptor. Uses, it is used in the treatment of glaucoma, so that caustic the pupils during the eye surgery. The next drug is bethanechol. So in case of bethanechol, you can observe there is a presence of beta methyl group. If you observe the structure of carbachol, similar type of structure is present in bethanechol. Only the changes is that this CH3 group is present. That is the only change which takes place in the structure. And this change or this substitution, it indicates that the drug is more selective towards the muscarinic receptor instead of nicotinic receptor. It makes hydrolysis, it avoids the hydrolysis or stable the hydrolysis also, and it becomes selective to the muscarinic receptor. Uses are UTI infection साठी आणि gastrointestinal atony, muscle tone lost their peristatic ability. So to avoid this, for the treatment of this one, these drugs can be given. The next drug from the ergovis, that is the pilocarpine. It is generally a naturally occurring alkaloid whose structure is differ from the SAR what we have seen the SAR of acetylcholine, but still it can act as a cholinergic drug. It is not selective to the muscarinic, unlike other ergovis. It can penetrate the eyeball, and generally it is used for the topical application. It is given in the treatment of glaucoma. So generally one mark question is asked. Give the example of cholinergic drug which can useful in the treatment of glaucoma, which is the naturally obtained. So the pilocarpine is the example which is the naturally obtained from the plant. It is alkaloid. It doesn't have a similar kind of structure what we have seen in case of acetylcholine, but still it having the ability to bind to the muscarinic or nicotinic receptor. It does not have any kind of selectivity, that is binding to the muscarinic receptor or binding to the nicotinic receptor. This is about the some information regarding the agonist drug or acetylcholine agonist drug or the cholinergic mimetic drugs. Next part, carbamates are generally resistant to the acetylcholine esterase. Okay, so why it is generally happening? Because the carbamate, they doesn't have the ester group. Instead of that, they are having the carbamate group. That means instead of this CH3 group, they are having the NH2 group. And when NH2 groups are there, it is difficult to break down this group. Okay, hence they are more resistant. So generally what happens in case of the enzyme acetylcholine esterase, which break down the ester. So how they break down the ester? So they consist of acetylcholine esterase as a last amino acid called as serine amino acid. This serine amino acid having the hydroxy group. And when this serine amino acid along with the hydroxy group, it comes in the contact with drug having ester group, what happens? The reaction takes place and the bond breaks from this side and this part bind to this side. So you are getting hydroxy group इथला H निघून जातो, O CO CH3 and remaining part hydroxy group इकडे येतो, OH remaining part as it is, and after that this breaking takes place into the acid, that is the acetic acid. But when amide group is present, it is carbamate group is present, it is difficult to break this bond and hence it becomes resistant to acetylcholine esterase. Next part, the enzyme called as acetylcholine esterase. So this enzyme, it hydrolyzes the acetylcholine into acetic acid and choline. So what is the mechanism of action of acetylcholine esterase? So it works by inhibiting the enzyme acetylcholine esterase and prevent the hydrolysis. So if we are giving the drug called as acetylcholine esterase inhibitor, so they inhibit the enzyme acetylcholine esterase, which is responsible to break down this acetylcholine into the acidic and alcoholic form, that is the acetic acid and choline. So these inhibitors, that is the acidic anticholinesterase or the cholinesterase inhibitor, what they do, they block this reaction so that acetylcholine remain as it is and it can perform their function. They promote the acetylcholine activity without binding to any receptor. They are called as indirectly acting cholinergic agonist. So directly means pilocarpine, betanicol, carbachol. Okay, so they bind to the receptor and they will perform their function. But the drug like anticholinesterase, which is also called as cholinesterase inhibitor, they will not bind to the receptor. But without binding to the receptor, they are breaking the bond, or they are responsible to inhibit the activity of cholinesterase. Hence, there is no breaking of bond of acetylcholine takes place, so acetylcholine remain as it is and it can bind to the receptor and will perform their function. So indirectly way, they are responsible to increase the cholinomimetic activity. So instead of binding the receptor, they are increasing the activity. So they are called as indirectly acting cholinergic agonist. This drug can be used to increase the muscle strength in myasthenia gravis, glaucoma, Alzheimer disease treatment, insecticide. Sarin gas is utilized as a chemical weapon. Okay, so anticholinesterase, they are utilized for this type of ways. And these drugs, anticholinesterase or cholinesterase inhibitor, they are of two types: reversible or irreversible. So these drugs, that is the anticholinesterase, their detail we will see in the next lecture.